Okay, now there are times when you work with the radicals, you will end up with a radical that cannot be simplified, especially in the denominator. So you see the rule is, anytime you work with an expression, radical expression, for example, yes, it's okay to have square root of 2 over 3. But you may not have 2 over square root of 3. That's a no-no. You have to rationalize or make it into a rational expression where the denominator is not a radical. This is okay. This is no good. So you could have whatever on top, you just cannot have a radical in a denominator section. So if you look at number 1, we have square root of 1 over 5, which can be written as square root of 1 over square root of 5. We did that on the last portion. I know what a square root of 1 is. It's simply 1. But square root of 5 cannot be simplified any further. However, you cannot leave your answer like that. You have to rationalize the expression, meaning make the denominator not radical. And to do that, you multiply to this quotient, the top and the bottom, by that denominator, which is square root of 5. Because in fact, by doing this, it's an identity. Square root of 5 over square root of 5 is simply 1. It's like not being there. So you don't really change any answer, you just change the form. But here's what happens. Square root of 5 times the square root of 5, that becomes square root of 25. And on the top, 1 times square root of 5 is simply square root of 5. But now here's the beauty. Square root of 25, you know it's a 5. And the top is square root of 5. It doesn't matter what the top is. As long as the bottom is not a radical, that is a good answer. That is a simplified form. Now you try number 2 and number 3. Alright, so when you write this radical expression into 2 separate radicals, square root of 5, square root of 6 is what you get. They're not simplifiable, if that's a word. But you cannot leave it like that as a radical. So you multiply to the top and the bottom by square root of 6. Because when you multiply square root of 6 times the square root of 6, you get square root of 36. And 5 times 6 is square root of 30. You wish you could simplify this, you cannot. Now, square root of 36 is simply 6. So you might be asking, does that mean each time I multiply 2 identical radicals, the radicand, the number inside, comes out? Yes, that's the pattern. And the top here is square root of 30, so that's your final answer on this one. So now that you see those 2 examples, you could quickly figure out what this is. You know this can be written as square root of 1 over square root of 2. We know what square root of 1 is. It's simply 1 over square root of 2. But since you cannot leave your denominator with a radical, you multiply to the top and the bottom by that same denominator. So here's the quick one. Square root of 2, the radicand comes out. 1 times the square root of 2 is square root of 2. There you go. So now, number 4. If you try to rationalize this guy, what you end up getting is negative 4 times the square root of 1 over square root of 10. You know, you could separate the quotient into 2 separate radicals. I know what a square root of 1 is, so it becomes negative 4 times 1 over square root of 10. Now that cannot be simplified any further. So to get rid of the radical, you have to multiply to the top and the bottom by that denominator, which is causing you the headache. And now square root of 10, you know the radicand is going to come out. So negative 4 times 10 comes out, and 1 times square root of 10 is just square root of 10. Now you know you can reduce this. The common factor between 4 and 10 is 2. So 2 reduces the 4 twice. 2 reduces the denominator 5 times. Your final simplified answer is negative 2 square root of 10 over 5. Looks like more of a mess, but in fact, this is a simplified form of this guy right here. So now you try this one. All right, so you said, well, let's write this as two separate radicals. Square root of 21 over square root of 35. You know what? How about instead we do it this way? I just realized a better way. Isn't square root of 21 and 35, don't they have a common factor of 7? So in fact, if you reduce it, you get square root of 7 times 3 is 21, and 7 times 5 is 35. So there's a simplified form. Now, you multiply to the top and the bottom by that simplified radical, because 5 times 5 square rooted becomes 5, and 3 times 5 radical becomes square root of 15. And no, 5 is not inside a radical, so 5 cannot reduce 15. You wish you could, but no, no, no. That becomes the final answer. So finally, number 6. So if we use the same trick we did number 5, 6 and 18 can reduce. So it becomes 2 times the square root of, well, 6 goes into 18 3 times. And now if I write that as 2 separate radicals, square root of 1 over square root of 3. Square root of 1 is simply 1 over square root of 3. Trying to get rid of the denominator radical, so multiply to the top and bottom by that square root of 3. So 2 times 1 times 3 numerator is square root of 3 over the radicand comes out, because they're identical, 3. And I think this will be the final answer. Or if you wanted to, you could say 2 times the square root of 3 over 3. Either way, you get the same answer. There you go.